So today we discuss electric flux. Electric flux. So what is electric flux? So before the discussion of electric flux, we discuss what is electric field. Okay, that's very important. The concept of electric field, and you know that electric field is a vector field, and E, that is a vector, some constant K, and you know the K equal to 1 over 4 pi epsilon naught, and epsilon naught is permittivity of free space. Okay, and here that Q source charge over r square the distance, and there is a r cap, because electric field is a vector field. Okay, so what is flux? Flux is a number of electric field or in over area. Okay, so number of electric field in unit area. Okay, so the phi, the flux, represented by E, electric field, and that area A, if area considered the vector. Okay, so that is the flux phi. Suppose we consider any arbitrary surface, and there is a source charge inside. Suppose the Q source charge here, and electric field is outward direction. Field is outward direction. Outward direction. Now we consider that area A. Suppose we consider that area A. Okay, and the area vector in that direction, area vector, and electric field in same direction E. Okay, electric field and area are in the same direction. So phi is the scalar quantity, electric flux, that is equal to electric field in unit area. Okay, multiplied by this. So now if I consider the small amount of area here, suppose that is a delta A. So phi, that is E dot dE or delta A, close integral, closed surface integral. Here the closed surface integral. Okay, and E and dA, that's very important, that is a dot product, that is phi is a scalar quantity, is a scalar quantity, and E and D are the both vector quantity. Okay, so SI in the flux, the SI unit is E times dA. So here the SI unit of flux, that is equal to electric field is a Newton per coulomb. Okay, Newton per coulomb, and the area is a meter square. So we know the electric field is a Newton per coulomb and area is a meter square. That is the SI unit. Okay, the SI unit of flux. Okay, and SI flux is a scalar quantity. Now flux with a positive, negative, and there is zero flux. Okay, when positive flux, the concept of positive flux is suppose we say that if the flux is positive, when suppose the flux positive means electric field in that direction, area with the same direction, so theta is a 0 degree. So phi equal to EA cos 0, and cos 0 be the 1, so E times A. So here the positive flux. And now the another case, if there is a source charge with a negative, suppose there is a area considered, and the area vector in outward direction, but in negative source charge Q, so electric field is inward direction. The angle between these two, so phi, that is equal to EA and cos 180, and cos 180 represent, that is a minus 1. So minus flux or minus EA. So here is the negative flux. Negative flux. And now another case, case number 3. There is a surface. and that electric charge here, positive charge, and electric will just touch the surface and passing through that, skimming the surface actually. Just touch like a tangent of that point. Okay. So here the electric field in that direction and area in that direction, that area vector A, consider a small area A. So here the flux phi, that is E A cos 90. Cos 90 with a 0. So there is a 0 flux. That is a 0 flux. And the important concept is that in case of 0 flux, the surface and inside that surface there is no charge. No charge inside the surface. If inside the surface has no charge, means the phi is a 0. Okay, clear? That's very important. If the inside charge is 0, so flux is 0. If the inside is a minus, there is a negative flux. And if the inside is positive, there is a positive flux. So flux is a scalar quantity and phi you get E times area if I integral from E dot dA, and there is a closed surface integral here. Okay, the phi equals here closed surface integral. There is a basic 5 minutes of there's a basic of 5 minutes of electric flux. If you want to more about what is electric flux and what is the concept of electric flux and other concept of electric field, okay, more detail, there is another lecture. Okay, I put that lecture in I button, or here is a playlist. I also put that playlist in I button. You click that I button, you get that lecture. Okay, so end that lecture here. Thank you.